Welcome to this BiofilmQ tutorial. My name is Hannah and today we're going to have a look at the different scatter plot options in the Visualization tab. You can see that I have already loaded a directory here. In previous tutorials you have learned how to do so, as well as gotten an overview over the different areas in the Visualization tab. The directory that I have loaded contains a biofilm growing over time, where I have two channels, one of which corresponds to a constitutive reporter that I use for segmentation, and the other one is a translational fluorescent reporter. Today we are going to discuss two of the top plot types in this drop-down menu, which are the 2D XY scatter plot and the 4D XYZZ scatter plot. We'll start with the 2D XY scatter plot. For a start, we will have a look at the biofilm at a specific time point. So I will choose and select one time point in this table over here on the left and click on selected images. We want to plot now the thickness of the biofilm in space. So I will choose the centroid coordinate x as well as centroid coordinate y for my x and y axis. And as a color code for this map, I will choose local thickness. Note here that even without a color code, I could already perform the plotting because the color is optional for this 2D XY scatter plot. However, I want to use the local thickness. And if we now click on plot, you can see the distribution of the local thickness in space. You can see that there are areas where the biofilm is very thick, and there are also areas where the thickness of the biofilm is 5 microns or even lower, which probably corresponds to just a few cells attached to the substrate. Now for the thickness, I don't actually need to know the third dimension, because if you think about it, if you look at one point in the biofilm, it doesn't matter at which Z coordinate you look, the thickness will always be the same. So this type of plot is very good for visualizing, for example, two-dimensional distributions. However, if, for example, I want to look at the reporter activity, I would like to look at it in a three-dimensional space because it's possible that the reporter has a dependence on the distance from substrate. So I want to add the centroid coordinate z to my plot. In order to do so, I switch plot type from my 2D XY scatter plot to my 4D XYZZ scatter plot. For my z-axis, I choose the centroid coordinate z. And now for the color code, I switch from local thickness to mean intensity channel 2, which corresponds to the reporter. If I plot this now, you can see that each cube is represented by one point in this plot. You can see the rough outline of the biofilm. And if I move around, you can observe that there are some areas where the reporter is bright and some areas where it's rather dim. However, due to the density of points, it's hard to look inside the biofilm. If you want to do that, we can, for example, apply filtering. Filtering will be explained in an additional tutorial, but it's very useful for these types of plot, so I'm also going to mention it here. We can filter by clicking on the variable or the parameter that we want to filter by, in this case centroid coordinate y, and then clicking on the little plus next to the filtering gating field. And you can see this expression appearing here in filtering gating, where I can now choose a condition. In this case, for example, I can choose that the centroid coordinate y needs to be larger than 250. If I again click on plot, you can see the biofilm as it was before. However, now it's cut open. At this position, y is 250, and we can have a look at what's going on inside the biofilm. So this is really helpful. I want to show you another option of using this plot. That is particularly helpful if you have a time series. I will now click on all images again at the image range, because what we now want to do is we want to visualize the time development of the biofilm and of the biofilm thickness. So remember, for the thickness, I only need centroid coordinate x and centroid coordinate y in order to show what it looks like. So now as my z-axis, I have a free parameter which I choose as time. For my color code, again, I choose the local thickness. In order not to overload the plot with a lot of points, which will lead to long rendering times, I will apply another filter by clicking on local thickness, clicking on the plus next to my filtering gating box, and changing the condition to local thickness greater than 5, because we only want to look at areas of the biofilm where the thickness is 5 micron or more. Then if we click on plot, we can see the time evolution of my biofilm. Now we have again x and y as the axis here, but my z-axis is now the time. So this is how the biofilm grows over time. And if we turn it and have a look at it from different angles, we can see how over time the thickness increases and also the diameter of the biofilm increases. So with this visualization, you can also look at time series. Now I have shown you only a few examples on how to use the scatterplot option. Of course, there are a lot more things you can do, and you can just play around with your parameters and your calculations and see how to make the best plot to answer your question. Further tutorials, the other plot types are discussed, as well as the filtering gating method and the advanced options to apply custom scripts.